Ever wish you had X-ray vision? Not for superpowers or anything, but like, just imagine being able to look at a plant and instantly know if it was healthy or not. Turns out, in the world of agriculture, we've got something pretty close.
True.
Today's deep dive takes us into the fascinating world of NDVI. And trust me, this isn't just for people who can tell their petunias from their poppies.
Definitely not. This is going to be relevant to anyone who eats, which is all of us.
Yeah.
And what I find so fascinating is how NDVI takes something as basic as the color of plants and turns it into this powerful tool for understanding the health of our planet.
Okay, so no more stalling. What is this NDVI thing? We've got some insights from the folks over at Farmonaut, a company that's making waves in agricultural tech.
They really are. In the simplest terms, NDVI, or Normalized Difference Vegetation Index, is like a plant health detector.
Yeah.
You know how a healthy plant is usually a vibrant green? Well, one that's struggling might look kind of faded or yellowish.
Yeah, totally. Like when I forget to water my basil plant, talk about not a pretty sight.
Exactly. That color difference is key. See, plants, they absorb and reflect light in different ways, and it all depends on how much chlorophyll they have. You know how chlorophyll is that pigment that makes plants green?
Right. It's vital for photosynthesis, the process of turning sunlight into energy.
Precisely. So healthy plants, they're packed with chlorophyll, and they absorb a lot of visible light, especially red light, for photosynthesis. But they reflect a good deal of near-infrared light, which is invisible to our eyes. Now, unhealthy plants, on the other hand, they haven't got the same chlorophyll levels, so they actually end up reflecting more of that visible red light back.
So it's like they're saying, not enough energy to absorb this red light back at you.
You got it. And NDVI uses this difference in reflected light to give us a readout. It basically takes the difference between the near-infrared and red light reflections and then divides it by the total amount of those two types of light. Sounds technical, but really it's just a clever way to get a single number that's your NDVI value, and that gives you a snapshot of plant health.
So it's like taking a plant's temperature, but like using light. I like it. Now, Farmonaut mentioned that these NDVI values, they actually fall on a scale. What's the deal with that?
Think of it like a rating system, from -1 to +1.
Okay.
At the very bottom, from -1 to 0, you're looking at anything BUT healthy vegetation. We're talking bare soil, rocks, water bodies, essentially, lifeless landscapes.
So if you're seeing NDVI values in the negatives, time to pack a picnic basket, not a gardening trowel.
Exactly. Now, as we climb that scale, from 0 to zero point 0.1, we might encounter a bit of sand, rock, maybe a dusting of snow. Things are still looking pretty sparse.
Right.
Between 0.2 to 0.5, though, we start to see some green. Think grasslands, maybe crops just beginning to sprout. This is where plants are hanging on, but not exactly thriving just yet.
It's like the plant world's equivalent of getting there, but send pizza and water.
You've got that right. Now, things really get exciting as we move into the 0.6 to 0.9 range on the NDVI scale. This is where we see lush, healthy vegetation, think thriving forests or fields of crops in their prime.
Now we're talking. That's the dream, right?
Yeah.
Healthy, vibrant landscapes.
Absolutely.
But what happens if we hit that 0.8 to 1 mark on the NDVI scale?
Now that, my friend, is the plant world equivalent of peak performance. Think rainforests teeming with life or fields of crops so green they practically glow. Those plants are operating at peak efficiency, absorbing maximum sunlight and converting it into energy.
Okay, that's pretty amazing. But while this scale gives us a general idea, how does knowing this help us in the real world? I mean, outside of maybe impressing our friends with our newfound plant knowledge.
That's where things get really interesting and where a company like Farmonaut comes in. They're taking this simple idea of measuring reflected light and turning it into actionable insights, not just for farmers, but for all of us. But we'll dive into that more after a quick break.
All right, so we got a handle on this whole NDVI thing, how it works and what those values actually mean. But before we go any further, you mentioned that Farmonaut is taking this even further. What exactly are they doing with this technology?
Well, imagine this. You're a farmer. You've got hundreds of acres of crops. Instead of walking every single row just to check for signs of stress, what if you could get a bird's eye view of your entire farm and instantly pinpoint the areas that need attention?
Okay, that sounds seriously handy, especially if you're not exactly keen on a marathon every day. So how does NDVI make that possible?
That's where the magic of satellites comes in. Farmonaut uses satellites that are equipped with special sensors to capture NDVI data from space. These satellites are constantly orbiting the Earth, snapping images of the ground below, and that includes farmland.
So it's like having this fleet of high-tech scouts that are constantly reporting back on the status of all your crops from space.
Exactly. Farmers can log into Farmonaut's platform, on their phone, their computer, whatever, and access these NDVI maps. They can see the health of their fields, they can compare different sections, and they can even track changes over time.
So it's like having Google Maps for your crops, but with this color-coded health check included. That's incredible. But what happens if a farmer is looking at this map and they see a patch of their field looking a bit off? Like, what's the next step?
That's where Farmonaut's AI system, GVAI, steps in to provide some serious brain power.
Ah, AI. Always got to make an appearance these days, right? But seriously, how does Jeev AI actually help farmers in this situation?
So let's say you're a farmer and you're dealing with a sudden heat wave, which, as you can imagine, is stressful for thirsty plants.
Right.
Jeev AI, it springs into action. It combines NDVI data with up-to-the-minute weather forecasts and your field's historical data. It then crunches all that information to recommend adjusting your irrigation schedule, potentially saving your crops from drying out.
So it's like having a supercomputer whisper in your ear like, hey, you might want to give those tomatoes a little extra water today. That's incredible. But NDVI can do more than just tell us how much water a plant needs, right?
You're absolutely right. Remember how we talked about NDVI acting like this early warning system for drought stress?
Yeah, like those early warning signs are crucial. Catching things early is key.
Exactly. And it's not just about individual plants either. Imagine being able to track drought conditions across entire regions or even continents using NDVI data. This has huge implications for global food security, especially as climate change is making weather patterns more unpredictable. We're talking about potentially anticipating food shortages before they even happen and taking steps to mitigate them.
That's a game changer, not just for farmers, but for all of us who rely on a stable food supply. It's like NDVI is giving us a glimpse into the future of our entire food system.
It really is. And the best part is that the potential of NDVI, it extends far beyond just drought monitoring. Researchers and scientists are using this technology for everything from tracking deforestation to monitoring the health of coral reefs.
Wow, I had no idea the applications were so diverse. It's amazing how something as simple as measuring reflected light can unlock so much information about our planet. But hold on a sec. Earlier, we were talking about this NDVI scale, and I can't help but wonder, are there other ways to measure plant health from space?
You're right to be curious. NDVI is incredibly useful, but it's not the only tool in the toolbox. There are other vegetation indices out there, each with its own strengths and weaknesses. The Farmonaut article that you shared, it mentioned a few of them, EVI, SEVI, and NDWI. Have you had a chance to take a closer look at those?
I have, and I'll admit, I'm still wrapping my head around all the acronyms. It's like learning a whole new language. Is there a way to break down these different indices, maybe like a cheat sheet for those of us who haven't quite reached like plant whisperer status?
Absolutely. It can definitely seem like a lot to take in all at once. A simple way to think about it is that each index is like a different lens through which we can view and analyze vegetation. They all use reflected light, but they focus on different aspects or wavelengths, which gives us a more complete picture of what's happening.
Okay, I like that. Different lenses for different perspectives. So tell me more about these other indices. What makes them unique? What are their superpowers? Okay, so we're talking about different lenses, different ways of seeing the plant world. Tell me more about these other indices. What makes them unique? What are their superpowers?
Well, take EVI, or Enhanced Vegetation Index. It's like NDVI's more sophisticated cousin. You see, NDVI can be a bit sensitive to things like atmospheric conditions, haze, clouds, you name it.
Yeah.
EVI is designed to cut through that noise, giving us a clearer picture even on a hazy day.
So if NDVI is like taking a snapshot with your phone camera, EVI is more like using a high-end lens filter to get that perfect shot.
Precisely. Then there's SAVI, the Soil Adjusted Vegetation Index. Now, this one's a real problem solver when dealing with areas where there isn't much vegetation. Imagine trying to assess the health of a young sapling in the middle of a vast, bare field. The soil's reflectance can mess with NDVI readings, making it seem like there's even less green than there actually is.
Okay, so it's like trying to listen to a whisper in a hurricane. You need a way to filter out the background noise to hear what's really going on.
Exactly. SAVI swoops in to save the day by accounting for that soil interference, giving us a more accurate picture of those precious patches of green, even in the sparsest landscapes.
That's amazing. It's like each of these indices has its own specialty, its own niche in understanding plant life. What about NDWI? What's its claim to fame in this plant watching toolkit?
NDWI, the Normalized Difference Water Index. This one's all about, you guessed it, water. While other indices focus on chlorophyll and overall plant health, NDWI zooms in on the water content within the plants themselves. It's like a plant's internal thirst meter.
So, if a farmer is concerned about their crops getting enough water, especially during a particularly dry spell, NDWI would be the go-to index to check.
Exactly. NDWI can detect even subtle changes in water content, giving farmers a heads up if their crops are starting to get stressed. This early warning system can be the difference between a healthy harvest and a field full of wilting plants.
Wow, this is fascinating stuff. But it makes me wonder, with all these incredible indices to choose from, why does Farmonaut seem to rely so heavily on NDVI? Is it just a matter of keeping things simple?
That's a great question. There's a good reason NDVI is so widely used. See, it's like the trusty wrench in a toolbox. It may not be the fanciest tool, but it's reliable, versatile, and it gets the job done in a wide range of situations. There's also a massive amount of historical NDVI data available, which is incredibly valuable for tracking long-term trends in vegetation health.
So it's like the old saying, if it ain't broke, don't fix it.
In a way, yes, but it's also about building upon a strong foundation. Even though Farmonaut primarily relies on NDVI, they're constantly refining their algorithms and incorporating data from other indices as needed. They might use EVI to correct for atmospheric interference on a cloudy day, or SEVI to get a clearer picture of vegetation in arid regions.
Okay, that makes sense. So it's less about choosing one index over another and more about using the right tool for the job, or even combining multiple tools to get the most accurate and insightful data possible.
Exactly. And that brings us to the really exciting part, the future of this technology. We're on the cusp of some incredible advancements that could revolutionize how we monitor and manage our planet's resources.
Okay, now you've got me on the edge of my seat. We talked about NDVI and its superpowered cousins, but what's next on the horizon? What does the future hold for plant power?
Well, imagine this. Instead of just seeing whether a plant is healthy or stressed, we could pinpoint the exact nutrient it's lacking, or even diagnose disease before any visible symptoms appear. That's the promise of hyperspectral imaging.
Hyperspectral imaging. That sounds like something straight out of Star Trek.
It might sound futuristic, but it's closer than you think. Remember how we talked about different indices focusing on specific wavelengths of light? Well, hyperspectral imaging takes that to a whole new level. Instead of just a handful of bands, it captures hundreds, even thousands, of very narrow bands of light, giving us a far more detailed look at the composition of plants.
So if NDVI is like listening to a basic AM radio, hyperspectral imaging is like tuning into a high-definition surround sound system. We're talking about a whole symphony of data.
A perfect analogy. And with all that data, we can start doing some really incredible things. Imagine farmers being able to identify a potential pest infestation before it even takes hold, or researchers tracking the spread of plant diseases in real time.
It's like giving every plant a personalized health checkup, all from space. That's mind-blowing.
It really is. And it's not just about the technology itself, but how it's integrated with other advancements, like AI and machine learning. Imagine a network of sensors embedded throughout a field, continuously monitoring everything from soil moisture to nutrient levels. All that data, combined with hyperspectral imagery from above, would create this incredibly detailed and dynamic picture of the entire ecosystem.
So it's like taking the concept of precision agriculture to a whole new level, making informed decisions not just field by field, but plant by plant.
Precisely. And it's not just about increasing yields or maximizing efficiency either. It's about creating a more sustainable and resilient food system for everyone. We're talking about using technology to minimize waste, reduce reliance on pesticides and herbicides, and ensure that we can continue to nourish a growing population while protecting our planet.
You know, it's incredible to think that it all circles back to something as fundamental as the color of plants. It really makes you appreciate the power of observation, scientific curiosity, and that drive to understand the world around us even, or perhaps especially from space.
Couldn't have said it better myself. Sometimes the most groundbreaking discoveries come from asking simple questions and then daring to delve deeper to see what hidden wonders the universe might reveal.
Well, I think that's a perfect note to end on. Next time you're enjoying a fresh salad or admiring a field of wildflowers, take a moment to appreciate the incredible technology that's helping us understand, appreciate, and protect the vibrant tapestry of life on Earth.
Indeed, a world of hidden wonders awaits those who are curious enough to look.